I'm Jonah Comstock, Editor-in-Chief of Pharma Forum. I'm here on the sidelines of JP Morgan 2024 at the Marker Hotel. I'm joined by Jeff Smith, the Chief Research Officer at Precision BioSciences. Jeff, it's good to have you here.
Thank you. I'm excited to walk through the very exciting story that is Precision BioSciences with you.
Yeah, all right. Well, tell me about the company a little bit. What do you do? What's your story, and what are you here to talk about this year at JP Morgan?
Sure. So, taking you sort of all the way back, my background is actually has always been in gene editing. As a graduate student, I helped develop some of the first gene editors, customizable gene editors called zinc finger nucleases, and helped to develop, actually in collaboration, some of the first examples of in vivo gene editing with those. And then went to from Johns Hopkins to Duke University, where I did my postdoc, and there actually joined up with a good friend of mine from Hopkins that also worked on the gene editors, and we were still had a passion for figuring out, and we knew the limitations. We wanted to come up with a better tool, and so we set to it. And after about 2 years at Duke, actually invented ARCUS, which is the foundational technology for precision. And the part of the impetus of that was coming up with something that we knew overcame some of the limitations we knew currently in the field. And then from there, we rolled it out of Duke University. And actually, it was sort of funny. Got largely our start at a 2-year-old's birthday party, where fortunately the other co-founder had sat down at a table and met somebody that was an MBA, and the MBA was looking for an idea, and we were looking for somebody to help roll out the company, and that's how we ended up generating the first team that rolled out the technology.
So, how does your company, your methods, your product differ from some of these other gene editing companies, especially maybe some of the ones that have been in the news recently?
Yeah, that's a great question. So you're never going to see another one like ARCUS, in that so many of the gene editors on the market now are CRISPR based. So they have a Cas9 with a guide RNA that's trying to find the target sequence. In our case, ARCUS is derived from a totally different set of enzymes called homoendonucleases. And why that's really critical to the story is that homoendonucleases evolved in nature to insert DNA safely by a process called homology-directed repair. And so what we've done is we've been able to re-engineer ARCUS to be able to target a new DNA sequence of our choosing, but maintain that naturally evolved function. And where that's really key is that it allows us really 3 differentiating advantages over other gene editors. The first is that ability to drive that homology-directed repair. And it turns out that sort of relates back to the way that the enzyme cuts the DNA. It generates this very unique 3' 4 base pair overhang. And that allows us to drive a very high insertion rate. And what was really surprising is when we look at those insertions, most of them are by homology-directed repair. Even in non-dividing cells, which if you read literature and you look at all the other gene editors, basically all the other gene editors will claim that that's not possible. And but we have definitely found ARCUS, I think partly, like I said, because of how it evolved, is able to do that. The other key differentiator is size. ARCUS is actually the smallest gene editor on the market. Why that's really important is it allows us to actually co-package ARCUS with either another ARCUS to actually go in and make two cuts and excise a big piece of DNA, like we're doing with the Duchenne's muscular dystrophy program. It's also able to uh, package uh, a ARCUS with a repair template all in one AAV, which is a delivery vector that allows us to target for gene insertion outside of the liver, which again is something that people really are hoping to do, but nobody else is really there yet. But ARCUS actually can. And then the last one, as far as a key differentiator, is that most of the other, especially newer Cas-based gene editors, are all fusion proteins. Your base editors are fused to a deaminase. Your prime editors are fused to reverse transcriptase. But in our case, everything we need is all packaged in one protein, which again means it's smaller in size, less complex to deliver. But in addition to that, the DNA recognition, so recognizing the right site, is actually tightly controlled with the DNA cutting. So only when the enzyme actually binds to the correct site does it activate to cut, to actually make the cut and do the edit. In many other cases, with a fusion protein, and this is the case from my background with zinc finger nucleases as well, is that the effector domain, so the nuclease or the deaminase or whatever does the action, is separate from the DNA binding. So there's no communication between the two. So I always liken it to my teenager dragging a lawnmower behind him. You hope that he gets to the right spot of the lawn, but there's no guarantee that the lawnmower is not going to do something on the way. In the case of ARCUS, we're actually able to uh, uh, target the right site and only act at the right site.
Hence the name Precision.
Correct.
So then, do you is ARCUS the product? Are you selling the gene editor, or are you then using that to develop therapeutics?
So we have spun out to actually, so over the history of the company, initially we were selling the editor, but we have evolved to developing our own therapeutics with it. We have the lead internal program is for hepatitis B, where we are uniquely using ARCUS to eliminate the underlying cause of the disease, to eliminate the cccDNA, to knock out any integrated virus. We also have a program that we recently announced where we are going into muscle to shift the what's called heteroplasmy of the plasmids or the mitochondrial genome. And in that case, to be able to address primary mitochondrial myopathy.
So obviously, a lot of eyes are on this space now because of the double FDA decision in December in the sickle cell space.
Mhm.
Do you think that 2024 is going to be a big year for gene therapy in terms of approvals? Do you think that the space is going to make a lot of progress?
Definitely, I do. I think it's one of the sort of like the snowball rolling downhill. That what was sort of hindering a lot of the market, in my opinion, was that there wasn't very clear. There was no book written as to how to get through the FDA and regulators. And as more things get through and approved, it sort of sets out that track that others can follow. And so I think that it will pick up steam, and more approvals will be coming through.
Any other thoughts or predictions about what you're looking forward to this year in your space specifically, or biotech more broadly?
Well, specifically for our space, probably the thing I'm most excited about is that a lot of eyes are shifting from sort of the simple knockout, so just knocking a gene out, to what I would call gain of function, where you're actually trying to insert or replace a defective gene. And I think a lot of efforts and a lot of interest has been shifting towards gain of function. And I think ARCUS is particularly well positioned because of its high insertion rates and being able to do it by HDR, or homology directed repair, that it is very well positioned to be able to excel in that gain of function field.
Wonderful. Well, thank you so much, Jeff. It's been really interesting to learn about what you do. And yeah, I think this is going to be an exciting year for this whole gene therapy space.
Okay.